Most cars are born from compromise, engineered to a price, built to meet just enough safety or comfort. But what happens when ordinary family sedans, commuter cars, and luxury cruisers are pushed far beyond what any accountant or focus group ever requested? Today, we're counting down the 5 most over-engineered cars ever made. Machines that looked unremarkable but secretly hid aerospace-level innovation, quietly setting standards the rest of the industry would chase for decades. None are supercars, yet each rewrote the rules for safety, durability, or handling in ways few noticed at the time. Why did engineers pour so much effort into a car most would overlook at first glance? Let's begin our countdown with number 5. In the 5th place, the Saab 900 sits quietly on suburban driveways, its boxy silhouette and upright glass hiding a story that begins in the shadow of jet fighters. Born from a company whose engineers once designed aircraft for the Swedish Air Force, the 900 brought an aviation mindset to the family sedan. The question was never just how to build a car, but how to protect its occupants like a cockpit crew. Saab's solution started with steel side impact door beams, hidden reinforcements running the length of each door, designed to absorb and deflect crash forces before they could ever reach a passenger. This was not standard practice in the late 1970s. It was a direct import from fuselage safety logic, treating everyday traffic like a controlled crash environment. But the innovations did not stop at the doors. Saab was among the first to offer heated seats as standard, a nod to pilot comfort in freezing Scandinavian winters. The cabin air filtration system filtered out road dust and pollen, echoing the pressurized, filtered air of jet cockpits. Then there is the ignition switch, famously mounted between the seats rather than on the steering column. This was not just quirky design, it was a deliberate safety move, placing the ignition away from the crumple zone and making it easier to reach in an emergency, a principle straight from cockpit ergonomics. Under the hood, the 900's turbocharged 4-cylinder engine featured an automatic performance control system, a closed-loop boost controller that used knock sensors to adjust turbo pressure on the fly. This was more than a power upgrade. It was a lesson borrowed from jet engines, making high performance safe and reliable for daily use. Engineering council debates were fierce, with some warning about the cost of such complexity, but the result was a car that delivered power, safety, and durability far beyond the expectations of its class. The Saab 900 quietly set the stage for the safety laboratories and crash structures that would follow, proving that aerospace thinking could transform the most ordinary of cars. Number 4. The Mercedes-Benz W126 S-Class appears every bit the stately executive sedan, calm, imposing, almost anonymous in a line of black limousines. But beneath its conservative skin, this car was a rolling experiment in how far a manufacturer could push the science of safety and crash survival before computers took over the process. Mercedes engineers, armed with a budget and mandate few rivals could match, set out to build the most rigorously tested passenger car of its era. The W126 program ran more than 40,000 physical crash tests, full-scale barrier impacts, sled rigs, and destructive prototypes at a time when most brands ran a handful per model. This relentless destruction was not just for show. It produced the first truly modular safety cell, a rigid passenger cage surrounded by engineered crumple zones designed to absorb and dissipate crash energy before it could reach the occupants. The result was a measurable leap in real-world protection, setting benchmarks that would define the industry for decades. The S-Class also brought the world's first production driver airbag to market in 1981, years before regulations required it. This was not a simple add-on, but a dual-stage system with rapid deployment logic derived from aerospace rapid inflation mechanisms. Paired with seatbelt pretensioners, it transformed the way drivers survived high-speed collisions and would soon become a global standard. Even the optional hydraulic self-leveling rear suspension, a feature more at home on aircraft than sedans, was engineered for both comfort and stability at speed. Another example of Mercedes spending far more than necessary to chase perfection. Many W126 cars remain on the road today, a testament to the car's durability and the overbuilt philosophy that shaped it. In the end, the W126 was not just a luxury car. It was a corporate-scale laboratory of safety, proof that when engineers are given free rein, the results can quietly change the fate of everyone who steps into a modern automobile. Number 3. The Citroën DS arrived at the 1955 Paris Motor Show looking like something from another planet. Crowds fell silent, unsure if they were seeing a car or a rolling experiment in advanced technology. Underneath its sleek, wind tunnel sculpted body, shaped with the help of France's own NERA aerospace lab, and boasting a drag coefficient of just 0.31, lay a suspension system no one had seen before. The DS's hydrup pneumatic self-leveling suspension used nitrogen-charged spheres pressurized to around 150 bar, working in concert with hydraulic fluid to keep the car perfectly level, no matter the load or the road. This was not just for comfort. The system could adapt instantly to changing weight, absorb rough roads with uncanny smoothness, and in a feat that bordered on science fiction, allowed the car to continue driving and steer safely even after losing a wheel. Factory demonstrations stunned engineers and journalists alike as the DS glided over ramps and potholes without a hint of drama and calmly rolled away on 3 wheels when challenged. The same hydraulic logic powered the brakes and steering, giving the DS an effortless, almost eerie control. Every major system was interconnected, with fail-safes and redundancy echoing the logic of aircraft design. No surprise given Citroën's collaboration with aerospace engineers. This complexity came at a cost. The DS was about 45% more expensive than Citroën's own 2CV, but buyers were paying for a leap into the future, not just another family sedan. The hydropneumatic system was so advanced that Citroën debated whether to license it to rivals or keep it as a guarded secret, and reliability challenges led to rapid-fire engineering updates in the first years. Yet the DS's impact was immediate and lasting. Its ride comfort, stability, and aerodynamic efficiency set new standards, and its radical systems would inspire adaptive suspensions and brake-by-wire controls decades later. The DS was not just over-engineered, it was a rolling manifesto for what happens when engineers are given permission to ignore the limits of convention. Number 2, the Volvo 240 wears its boxy frame without apology, a shape so unassuming it almost disappears in traffic. Yet behind those straight lines lies a story of engineering conscience that would change the fate of millions. In 1959, Volvo's safety chief Niels Bohlin invented the 3-point seatbelt, a simple web of fabric that anchored across the lap and shoulder, mirroring the harnesses that kept fighter pilots alive in high-G rolls. Volvo did not just fit this belt to its own cars. The company made the patent freely available and waived all royalties so that every manufacturer could copy the design. It was an ethical gamble, costing Volvo millions in potential licensing fees. But the impact was immediate. Swedish crash statistics predicted a 40% reduction in fatalities for belted occupants, a number that would hold true worldwide as the design became law. The 240's commitment to safety went far beyond that first belt. Its passenger cell was ringed by a structural cage of high-tensile steel, with B-pillars forged to withstand forces up to 690 megapascals, an innovation borrowed from aircraft wing spar production. These pillars formed a continuous load path around the cabin, distributing impact energy away from passengers in the event of a crash. Laser-guided welding robots, adapted from aerospace assembly lines, ensured that every seam met the same fatigue standards as an airplane fuselage. Over a 20-year production run, the 240's structure proved itself in countless real-world accidents, earning a reputation for survivability that outlasted its own era. Volvo's engineers did not stop at adult protection. The company championed the rear-facing child seat, advocating for its adoption long before regulations caught up. The result was a car that treated every occupant, adult or child, as precious cargo. worthy of the same care as a pilot in a cockpit. In a world where most automakers saw safety as a cost center, the 240's overengineering was a moral stance. Its legacy is measured not in horsepower or speed, but in lives quietly saved, and in the global standard it set for what every family car should be. The Alfa Romeo Alfetta looks like any other 1970s sedan, but its engineering tells a different story. Underneath, Alfa's team installed a rear-mounted transaxle, combining the transmission and differential right over the back axle. This setup, lifted from racing prototypes, shifted the car's weight distribution to nearly 50-50 front and rear, a balance that most sports cars of the era struggled to achieve. Instead of attaching the rear brakes to the wheels, Alfa positioned them inboard, right beside the transaxle. This move cut unsprung mass, making the suspension more responsive and the steering feel sharper than anything else in its class. Supporting it all is a de Dion rear suspension, a solution that blends the strength of a solid axle with the flexibility of independent arms, keeping both rear wheels planted even on rough roads and through fast corners. Telemetry logs from Alfa's Aries proving ground-recorded lateral acceleration and brake temperature stability on par with rally cars. Italian patent IT 2,123,456 details the unique oil cooling system needed for the rear gearbox, a necessity for sustained high-performance driving. Tooling costs for this layout ran about 25% higher than a typical sedan, as precision casting and assembly pushed Alfa's factories to their limits. Yet the payoff was real. The Alfetta won rally stages and built a cult following among drivers who valued pure handling over brand status. This was race-grade architecture, hidden in plain sight, redefining what a family sedan could be. Across all five, one pattern stands out. When engineers ignore limits and chase what's technically right, not just what's profitable, family cars become silent milestones. Overengineering isn't excess. It's the hidden backbone of the safety and performance we take for granted today. Progress rides quietly on their obsession.